Okay, sine and cosine curves are two equations. Our y equals a sine of b times x minus c plus d, and y equals cosine a, and the same thing. A stands for amplitude, which is 1/2 the distance between the max and the min. Okay. B will stand for the period of the function, how long it goes until it repeats. So A is amplitude. So that's like the vertical stretch or shrink when you guys were doing this in Algebra 2. Now some of you are still in Algebra 2 and thus are still learning about it or haven't gotten to it yet. Okay? But that's the vertical stretch or shrink. The period is the horizontal stretch or shrink. C is the phase shift, left or right. And D is the vertical shift, up or down. So far, so good? Okay, unit circles, get them out.
Oh, yeah. Did they take it? No. I don't. I mean, I'm like, junk. That's enough.
Y equals sine of x. What's the sine of 0? What's the sine of pi over 4? What's the sine of pi over 2? 1. What's the sine of 3 pi over 4? Square root of 2 over 2. What's the sine of pi? What's the sine of 5 pi over 4? Negative square root of 2 over 2. What's the sine of 3 pi over 2?
Oh, 1, negative 1.
Negative 1. 7 pi over 4? Negative square root of 2 over 2. And 2 pi. We're back to 0 again. Okay. Yep. Shaw Daddy's room.
Yep.
Okay. So when I graph, normally I go 4 squares to get to pi over 2. Then pi would be 8 squares. 3 pi over 2 would be 12 squares. And 2 pi would be 16 squares. Okay? And then it all depends what my amplitude is, how many squares I go up and down to get to 1. Okay? But in this case, I'll go 2 squares. Now, if we're graphing y equals the sine of x on the graph below, 0, 0 is a point. 0, 0. Pi over 4 is halfway in between 0 and pi over 2, right? And that's square root of 2 over 2, which is about 1.3 something. At pi over 2, what's my value? 1. 3 pi over 4, it's about 1.3 something. Pi, we're at 0. 5 pi over 4 is right here. And we go down to 1.3 something. 3 pi over 2 is negative 1. And so that's what the sine curve looks like. That's one period of the sine curve. Now it continues on because we have coterminal angles, right? So using coterminal angles, we'd be here, and we just keep going this way. And coterminal angles backwards, we'd keep going this way. But in general, we graph from one period of it, which looks like that. That is the sine curve, okay? You'll know the sine curve by heart really quickly. Now, I'm not going to make you graph those points there, okay? The over 4s. Just get in general, make it a curve and go 0, pi over 2, pi, 3 pi over 2, 2 pi, okay? Sine curve. So let's look at the cosine curve. So we're going to try to pluck these values straight off your unit circle while we graph. See if we can do that. Okay, what's the value of cosine of 0? 1. So it's a 0.01, not 0, 0. You don't start from the origin. At pi over 2, what's the value? No, it's pi over 2. I skipped over pi over 4. 0. Pi, negative 1. Pi over 3 pi over 2. 2 pi. So if we would put those points in here, never go like this. Never go a straight curve like this and like this. I'll count it wrong, okay? Because it's not a straight line. It's a curve. It curves like this. And that's one period of the cosine curve. Okay? So that's graphing the cosine of x. Now we're going to add our a's and our a's and c's, I think we'll start with. And then we'll do a few problems, and then we'll add in the d's. And then on Wednesday, we'll add in the b's. Okay? So let's do this. Let's do y equals 2 sine of x. So to graph y equals 2 sine of x, okay, whoa, didn't mean to do that. One, 2, negative 1, negative 2. Pi over 2, pi, 3 pi over 2, 2 pi. Okay, so when we're graphing these, I want you, if you have colored pencils, to start bringing colored pencils to this class, okay? If you don't have colored pencils, that's fine. I have some of them in the drawer. But when we graph these, I want them graphed in different colors. Okay? So what I'm going to do is graph. Are you done already with that test?
No,
Oh.
it's not here yet.
Okay. Ah, this computer. Quit it. Really? Y equals sine of x. I want you to graph the normal sine curve. Where's the normal sine curve? 0, 1, 0, -1, 0. So I want you to graph the normal sine curve. And then the amplitude on this one is 2. That means it's twice as high, twice as low. So 0 times 2 is 0. 1 times 2 is 2. 0, -2, 0. So your graph should look like that. Twice as high, twice as low. It's got little squiggles in it, but it's not that bad. Thank you, Neely. Y equals -1/2 cosine of x. So I'm going to graph y equals the cosine of x first. What's the cosine of 0? 1, 0, -1, 0, 1. So the cosine curve. Ooh, that's ugly. But there you go. That's the cosine curve.
Like that first one, you see how it's pi/4?
It's pi/2 and 3pi/2. Come on, Mr. Bierschbach. Get it right.
Nice catch, Brian. Yeah,
Yeah, maybe he should.
let's try it out.
Brian, get up there right now. You got it.
All right. I have a scalp to itch.
Oh, does your scalp never itch at me?
My hair itches.
All right. So, if we take each one of those y values times -1/2, what's 1 times -1/2? -1/2, so we start here. What's 0 times -1/2? So the -1/2 is a flat little curve that looks like this. You can handle that, right? Okay. Now, we'll work with the C. So now we'll go y equals the sine of x minus pi/6. Okay. When it's inside the parentheses, it's opposite of what you think. When it's outside the parentheses, it's what you think. So, what is a minus? Would you think a minus sign would move something? To the left. But it's the opposite. This moves it right pi/6. Right by pi/6. Okay? So we're going to graph the normal sine curve, and then we're going to move it right pi/6. But we can't use 4 spaces to get to pi/2 and so on. Okay? So I'm going to use 6 spaces to get there this time. So I'm going to go 6 spaces to get to pi/2, 6 spaces to get to pi, 6 bases to get to 3 pi over 2, and 6 bases to get to 2 pi. 1, 2, -1, -2. Yeah, can. All right, so I'm going to graph the normal sine curve, y equals the sine of x. Because if you start with y equals sine of x, you have a point to go from. So the sine curve goes 0, 1, 0, -1, 0. Okay? To the right, pi over 6. Now, how many spaces do I go to get to pi? Not pi over 2, but pi. How many spaces did I go? 12. So right pi over 6 is 1/6 the way to 12. How many spaces is 1/6 of 12? 1/6 of 12.
She said 5.
2. So I'm going to go 2 spaces to the right for each of them. To the right, to the right, to the right, to the right.
No. No.
No Cupid shuffle fans in here, I guess. All right. Yeah, my singing could make glass crack or whatever. Yeah.
Glass crack.
Yeah. I could break glass with my horrible singing. No.
Let's do a musical.
No, let's not. Okay. Are we good with this? Okay. Now, so when do you change your axis? Whenever you divide by 3 or 6, you could either make these 3 to get to pi over 2 and then another 3 to get to pi, or you could go 6 like I did here because I have enough squares. Okay? So if you divide by 3 or 6, you need to either go 6 or 12 squares to get to pi over, or 3 or 6 squares to get to pi over 2. If you're not dividing by anything, or if you're dividing by 2 or 4, if you have a 2 or a 4 down here, then I would just go 4 squares to get to pi over 2. Now, could you do this one every single time? Yeah, you can. But what happens sometimes, we're going to change a period and get things really stretched out or skinny, and then it's going to change the x-axis. Okay? So, for right now, out of your books, section 2-1. Your first assignment of the day. Are problems 63 through 71, the odds, on page 117. All I want you to do right now is graph them. You do not have to talk about the period, amplitude, phase shift, anything like that. We'll do that in the second half. I just want you to be able to graph them. Now, I have graph paper. I like it when you put it on graph paper instead of your notebook. You don't have to rip that up, Mr. Mork. Relax. But I have graph paper over here if you want to use graph paper. Now, some people just can't not do it in their notebooks. So if you think you need to do it on a piece of paper instead of graph paper, you may. But I kind of like it in graph paper, page 117, 63 through 71, the odds. At 3 or 2:20-ish, I'm just going to do a few more problems throwing D in, and then we're going to talk more about amplitude, phase shift, range, all that stuff. Okay? So, no, I want them on your desk, and then at some point I'll walk around and correct them, but it'll be a completion grade.
Do you want me to show you my...
Yeah, you can show me yours now because you're taking off. And then, oh, here, I got to stop recording here a second.